ladies and gentlemen, welcome back. I got you here for a second. This is going to be a really quick jump in and out of the relationship between our cell potentials with E-cell, equilibrium, and Gibbs free energy. That's the new one we're going to introduce here today. So, we understand E-cell and we understand equilibrium. We know equilibrium represents that ratio of products to reactants, and we understand E-cell values. A couple of things that we know about them is that positive E-cell values are thermodynamically favorable, which means they're going to proceed in the forward reaction, which means they have really large K values. All right? And so, but if we have an E-cell value, if we want to figure out exactly where equilibrium does lie, what that ratio is, there is a mathematical relationship that we can use here to actually determine those values. And so it's not anything crazy. This is not anything that's complicated. You just have to understand if I have one of the values, I can use it to determine the other value. And so that's really all this is. This is just simple algebra here, all right? The one thing I would remind you of is that if I'm trying to get rid of log and simplify log off of something, I have to raise it to a power. For example, I don't know, what am I trying to think of here? If I had 523 equals log of k, remember I'd have to raise that to the 10, and that cancels out so that k equals 10 to the 523rd, right? That whole thing, get the equal sign on the right side here. So to get rid of the log, we just have to raise to a 10. That'd be the only trick that I could see tripping people up as far as solving between E-cell and K value. Now, the other side of this I do want to spend a little bit more time on is this whole delta G idea that we're going to get here. And so delta G is actually a predictor of thermodynamic favorability. And so that delta G is the predictor of thermodynamic favorability. A negative delta G means that I am thermodynamically favorable. A positive delta G means I am not. So a negative delta G is thermodynamically favorable. A positive G is not. All right? And the easiest way to remember about that is we know that E-cell values, positive ones are spontaneous, i.e. they're thermodynamically favorable. And notice my mathematical relationship here has a negative in there. I have to actually make the right side of this equation negative in order to mean that it's thermodynamically favorable according to Gibbs. All right, and Gibbs is a whole nother unit when we get to thermodynamics that we will cover, but really it's just telling us it's the predictor of whether or not something is thermodynamically favorable. And again, the mathematical relationship here won't go beyond me giving you an E-cell value and saying, hey, what's the delta G value for this particular reaction? Or I could give you a G value and say, hey, what's the E-cell value for this particular reaction? So it's not anything crazy. There is a new constant that's being introduced here, and so that is Faraday's constant. So F is equal to Faraday's constant, and its value is 96,485 coulombs per mole of electrons. And so that's my Faraday's constant value. This would actually be, I guess I could put E-cell there, and then N in that particular case is the mole of electrons transferred, and we get that from the balanced redox reaction there. All right. Okay, so nothing crazy. We'll get to the relationship between our Gibbs free energy and equilibrium at a later time in another unit. Not necessarily something that we'll actually try and tackle at this point. But this is a big three. This triangle of equations will come back over and over and over and over and over again. So these are the equations I would go ahead and put into memory so that I can have them on immediate recall. Okay? All right, we'll have some sample problems for you in class. If you have any questions, make sure you get it down. We'll get them addressed when I see you there.